Hello and welcome. Let's continue. Let's discuss the SAR for phenoprofen. So phenoprofen is formulated as phenoprofen calcium, and calcium salts are less hygroscopic, so it means the drug is very stable. Phenoprofen is a non-selective COX-1 and COX-2, so it means it binds to both COX-1 and COX-2 enzymes. So let's discuss the SAR. So first of all, the general SAR for propionic acid derivatives is that number one, the alpha methyl, we have an alpha methyl in the acid chain. This is the alpha methyl. This alpha methyl is very important because it enhances anti-inflammatory activity. It should be there. Number two is that propionic acid derivatives, we have both R and S isomers. And S isomers are more potent than R isomers. And the difference is because at this point, this methyl, when this methyl is here, it introduces a chiral center. And if we have a chiral center, then it means that it brings about isomerism. So we said chiral centers is 2 raised, we said that isomerism is 2 raised to the power of chiral center, so 2 raised to power 1 is 2. So we have R and S isomers. Now, the R isomer is converted to the S isomer by an enzyme called acetyl coenzyme A synthase. This is important because you can formulate this drug as a race mix mixture consisting of both the R and the S isomer, but in the body it will all be converted to the active isomer, which is the S isomer. Yes, let's continue. Now, at this position, we said all NSAIDs should have the acidic center and the hydrophobic center. So this is the acidic center and this is the hydrophobic center. So, number one, this acidic center should be located either 1 or 2 carbons away from the hydrophobic center. If you increase the number of carbons from, let's say, 2 to 4, then it corresponds to a decrease in activity. Number two, this phenoprofen calcium, at this point we have the carbonyl. When you replace this carbonyl, when you replace the oxygen, you have the oxygen. When you replace the oxygen with the carbonyl, you form a drug called ketoprofen. So ketoprofen has a keto group at this position. Then at this phenoxy should be in a meta position. When you change the orientation to maybe ortho or para in conjunction with the propionic acid chain, then it also corresponds to a decrease in activity. We're talking about this phenoxy. Yes. And then when there are specific substituents, let's say on the aromatic ring, this aromatic ring, let's say a chloro or a fluoro, that also corresponds to an increase in activity. Thank you for watching, and until next time, bye.